it. And so we are going to be looking at that first week of lessons. Some of you may have done some of these lessons already in the practice week a couple of weeks ago. If you did, just let me know, send me a message, and I can get that work from that week. You don't have to do it again. But in this week, what we're focusing on is getting to know our numbers. So in the pre-assessment that you guys took, we had some questions about the different kinds of numbers, integers, whole numbers, rational numbers. And so I just want to make sure you guys are clear on what those different kinds of numbers are. So we're going to go over those notes and how to identify different kinds of numbers and what we're working with those numbers. And after we go over that, you guys can ask me any questions you may have about numbers and any of the questions you might have about any of the practices that you need to complete this week in order to get your credit. And of course, we will see each other again on Wednesday in case you have any additional questions, and we'll have another class then and go over some more things as well. I hope everybody is nice and well rested from the weekend. This is going to be your first full week of classes, right? You're going to have classes from Monday through Friday this week. Last week you didn't have Monday, got to ease you in a little bit. And this is going to be your first full week. Okay, so I am going to just share my screen again just to show you where you should be looking today and what you should have open. So every week is going to be labeled. When I release the information, you will see it. And so you should have a red folder that says week 1, September 14th to 18th on the number system. Make sure you guys have that open. That folder, that's what you should be working on. And we are going to start with the warm-up here, which is, what do you know about numbers? So most of you have maybe done this already and told me what you already know about whole numbers, integers, rational numbers, irrational numbers, and real numbers. If you haven't yet, go ahead and put your comments in there for what you think these numbers are. Please put them in on the Schoology page. And we're going to start with our notes today. So make sure you have your real numbers notes open. So you can go here to real numbers notes, click on it, and then wait for it to pop up, and then say open assignment with Kami, and that will open the assignment for you onto your into your Kami like so. And so you can write directly on this document if you open it with your Kami. Okay. All right, so I hope everybody has their real number system notes up. I'm going to pull mine up so that we can go ahead and begin working on them. All right. Now I can share them. All right, so hopefully you guys all have your notes up. And so our objective for today, which we can go ahead and write in on that sheet, our objective is to make sure, or to identify the different parts of the real number system. All right, so identify the parts of the real number system. So your real number system, you all, are the numbers that we're currently working with. They are divided really into two parts, real numbers and imaginary numbers. Your real numbers are going to be any of the numbers that we're going to be dealing with in this math class. We're not going to be dealing with any imaginary numbers at all, so you don't have to worry about that. But we are always dealing with real numbers in this class. And those real numbers are divided into two categories themselves, which are rational and irrational. So we have rational numbers and we have irrational numbers. And a rational number, does anybody know what it means when I say rational number? What does that sound like? Ratio, anybody? Rational number? So a rational number is a number that is based on a ratio. What is a ratio? Anybody have any idea what a ratio is? Have you guys seen a ratio before? Nobody has seen a ratio? I don't believe you.
No, because ratio kind of too Solomonic size of value. Well, size of value. Let me just point that out there. Because usually they say the value. We say ratio basically is really size of two or more value. That one.
Okay, so a ratio is a comparison,
yeah,
right, of two numbers. So a ratio is anything that looks like can look like a fraction. So when we're talking about a rational number, we're talking about any number that can be written as a fraction. So let's go ahead and put these notes down in here so that we have that idea, right? So again, my objective is to learn the parts of the real number system. I don't want that. Let's change it to black. Real number system. I'm going to just use the number symbol so I don't have to write that much. All right. And so the real number system, so real numbers. So the real numbers are divided into two categories. Those real numbers are rational or irrational, right? Those are the two categories of our real numbers. So rational meaning that they can be written as a fraction, and irrational meaning that they cannot be written as a fraction. Okay, so that means that they don't have any fractional equivalent. Any number that we count with, so 1, 2, 3, 4, 5, 6, 7, those numbers like that, they can be written as a fraction, right? Because any of those numbers, let's say the number is 6, can be written as a fraction just by putting it over 1. So now it's a fraction, right? So remember that any number that we're talking about when we're counting and when we are talking about even some of our negative integers, those are also considered rational numbers because they can be written as a fraction. Any number that can be written as a fraction is rational, okay? So that's what we have here in our next definition, it says that rational numbers are the numbers such as 1/2 and 1/3 that can be written as a ratio of two integers, right? Or as a fraction, right? As a ratio of two integers, that's also known to be as a fraction, right? We all know that 1/2 and 1/3 are fractions. And then we have irrational numbers, which are like these examples here, which is the square root of 2 or pi. These are numbers that never end, and we have to approximate them, so they cannot be written as a fraction. Numbers that don't end or don't have a clear decimal equivalent are considered irrational numbers. And we have three kinds of rational numbers, okay? These numbers are the ones that we have here in these three tables. So we have integers, we have whole numbers, and we have natural numbers. All right, those are the three numbers that we have here in this table, and those are the three kinds of numbers that we are talking about when we're talking about rational numbers, okay? So those are any numbers that can be written as a ratio of two integers. Can anybody give me an example of an integer? What does an integer look like? What are integers?
Integer, I want to say letters and numbers combined.
No, that would not be integers. So letters and numbers combined would be algebra in general, but what is an integer? An integer is a kind of number. So we're not talking about letters at all, but what kind of number would be an example of an integer? Any other guesses? Anybody know what an integer is? All right. So our integers include numbers like -3, -1, 0, 1, and 3. So those are some examples of integers, but integers are negative and positive whole numbers. Okay, so your integers are your negative and positive whole numbers. Okay, so anything from -infinity to +infinity can be considered an integer, but it has to be a whole number. So it can't be a number with a decimal, and it can't be a fraction, right? So those are considered our integers. So our whole numbers are any number including but greater than 0, okay? So anything including or greater than 0. So we would say that any number greater than or equal to 0 is considered a whole number. So any number greater or equal to 0. So that means that negative numbers are not considered whole numbers. Negative numbers are considered integers, right? And integers include whole numbers, but whole numbers do not include integers because integers can be negative, okay? And then we have our natural numbers. Our natural numbers are numbers like 1, 2, and 3. or in this case, anything greater than or equal to 1. So they are the whole numbers except 0. So any of your counting numbers are considered natural numbers. Your counting numbers. Counting numbers excluding 0. We do not consider 0 a natural number because 0 is not really a number, it's a concept, right? Because you cannot essentially, you can't count 0. If you don't have anything, you have nothing. There's nothing to count. And so 0 is really a concept and not a number. It only becomes a number when it's part of some other numbers, right? Like in 10, 0 is a number, but it's not a number by itself. It has to be with that 1 to make it 10. So 0 is not really considered a number, it's a concept. So we have to understand that idea as we think about our different numbers. So what we're gonna focus on after this week is really getting into our integers and using our integers in addition, subtraction, multiplication, and division. And why that is because we have a lot of issues with our negative numbers in general. And so we're going to try to work really hard to dispel all of those mysteries around our negative numbers. We want to be able to multiply, divide, add, and subtract our negative numbers very well. So we're going to do that a lot beginning next week, okay? We have to understand these concepts of numbers first. All right, questions for the first part of these notes and these definitions? Okay, so I'm going to ask you guys a question then. Who can give me an example of an integer? Don't say it out loud. What I want you to do is to put it in the chat, but don't press enter. Just hold on to it for a second, but put it in the chat. So use the chat function and put your answer in there of what you think an integer is. Give me an example of an integer. And then I'm going to count you down. And then when I reach the end of my countdown, you can press enter. Okay? All right. So put your answers in. And now 3, 2, 1, enter. Good. That is correct, Toya. Good. That is correct, Ebony. Good. That's correct, Marvin. Where are the rest of you? What happened? What happened to the rest of my students? I see all of you. I see these names. I see these pictures and faces. Where are the answers? What is an integer? Give me an example of an integer. No? I'm not going to get an example from the rest of you?
Hold on, I'm getting one, Mr. G. I gotta get going. Integer.
Mr. G, I'm trying. I was on my cell phone in my car. I'm just logging in my house.
Okay, no worries. Okay, go ahead and tell me verbally then. What's an example of an integer, Renee?
I'm trying to see it because I'm driving.
Oh, okay.
Give me 1 second. I'm walking into my door.
All right. Perfect. Good job, Morris. Good job, Lucretia. All right. All right, so your integers are any negative and positive whole numbers. It includes 0, but okay, good. All right. So I think everybody's okay with integers. We're gonna move down this line and just take a look at this picture real quick. Let me clear these drawings. All right, so we have the real number system. Again, it's divided into 2 parts, rational and irrational. We are going to be working mostly on the rational side, right? The irrational numbers are numbers that we're thinking about that cannot be written as a fraction, right? Those are what those numbers are, right? They cannot be written as a fraction. I can put that note in here additionally for those of you who might need it. Again, right, irrational numbers cannot be written as a fraction. Okay, so your rational numbers, which includes anything over here on the left, right? So it includes integers, it includes whole numbers, it includes natural numbers, is anything that can be written as a fraction. Okay, so how do I turn a whole number into a fraction? What do I have to do to turn a whole number into a fraction? You can unmute yourself to tell me, or you can write it in the chat. But how do I turn a whole number into a fraction? What do I have to do to turn a whole number into a fraction? Let's say I have the number 13. How do I turn 13 into a fraction? All right, somebody wrote it in the chat. Let's see. Good. You put it over 1. Thank you, Toya. Okay, so I can turn any number into a fraction just by putting it over 1. So 13 over 1 is now a fraction, but it's still my whole number. No, not 13 over 100, Marvin. If I want to turn a whole number into a fraction and have it keep its value, I just put it over 1. Okay? Just put the number over 1. To turn a whole number into a fraction, you put it over 1. If I want to turn a decimal into a fraction, I put it over 100 or another number. We're talking about whole numbers. To turn it into a fraction, you just put it over 1. Okay. So what is 0? I talked about this earlier. What is 0? What kind of a number is 0? Is 0 a number? What did I say earlier about 0?
It isn't a real number.
I think I heard something. Somebody tried to speak, but I can't hear you.
You said 0 isn't a real number because anything by 0 equals 0.
Okay, so 0 is a concept, right? 0 is not really a number, it's a concept. We include it in our definition of what a whole number is, right? So it's included as a whole number, as a whole number. But 0 is more of a concept because you can't count 0. You just have to understand 0, right? Like if you don't have any, you have 0. So you can't count it. Good. All right. Excellent. All right. So we're going to try graphing numbers on a number line. So I have my number line here. My number line is a little crooked, unfortunately. I apologize. It's also in your notes crooked. But when we look at a number line, we read a number line from left to right, just like we would read a book, right? Or we read the text on this page. We read from left to right. So what kind of numbers are going to be on the left? Are they going to be bigger numbers or are they going to be smaller numbers on the left than when compared to the right? How do we do that? Where do the bigger numbers go? On the left or on the right when we're looking at a number line?
The bigger numbers go on the right.
Very good. So the bigger numbers are going to go on the right. So because the bigger numbers go on the right, On the left is where we would put numbers that are smaller and also numbers that are negative, okay? So we're gonna compare these numbers, A, B, the number sets in A, B, and C, using this number line. What we're gonna try to do is use the one number line. So I'm gonna start the number line in the middle by putting 0 in the middle. If 0 is in the middle, that means that on the left, I have negative numbers. And on the right, I'm gonna have positive numbers. Okay, good. So left is negative, right is positive. So then when I look at this number line, it's gonna be really easy for me to compare the two numbers that I have in part A, because I have -3 and 2. So -3 is gonna be on the left and 2 is gonna be on the right. So I'm just gonna count 3 places to the left from 0 to put my -3. So just 1, 2, 3. So -3 will be about here. So I'll put my -3. And then I'll count 2 places to the right to put my 2. 1, 2, and here's my 2. So how do I compare these two numbers then, -3 and 2? What symbol am I gonna use? Am I gonna use less than or greater than when comparing -3 and 2? What symbol am I gonna put in between them?
Less than?
Yes, because -3 is less than
Less than,
2,
I'm gonna say less than, but
right? So -3 is less than 2. When we're using these comparison symbols of less than and greater than, the mouth, and what I consider to be the mouth is this open part here, the mouth is always gonna be pointing towards the bigger number, right? So -3 is less than 2, okay? Because if you're hungry, you want to eat more. So I think that thinking of this as a mouth will help you think about which direction you should point. The mouth always goes toward the larger number. And then how you read it is depending on how the way that the symbol is pointing. This number is smaller, so I say -3 is less than 2, all right? Okay, let's think about letter B. I have -4 and -7. -4 and -7. So how would I compare those two, -4 and -7? What symbol would I use? Less than or greater than?
Greater than?
greater than.
Greater than, so it would look like this. -4 is greater than -7?
Yeah.
Yes, that's true, because if I put it on my number line, I'm gonna see that -4 is gonna appear right here next to -3, but -7, 1, 2, 3, is gonna appear all the way back here. And we know that the further you are to the left, the smaller you are. So -7 is definitely less than -4. So -4 is greater than -7. All right. And then of course we have 5 and -6. 5 is a positive number, so we know that the positive number has to be bigger than our negative number. So we're going to say 5 is greater than -6. All right. And if you need to, you can also graph that one on your number line as well. Just count 3 places from 2, 1, 2, 3, and you're going to put your 5 there. And then -6 will be just 1 place in from -7. And you can see that -6 is definitely smaller and more to the left than -5, than +5, excuse me. All right. So the value of negative and positive numbers when we're comparing them should be pretty straightforward. Are there questions though about that? No, everybody's good?
Yeah.
Okay. So here's a concept that's a little bit harder to understand. The concept of absolute value. Has anybody heard of absolute value before?
No.
Okay. So absolute value, when we talk about absolute value, we're just talking about a number's distance from zero. What does that mean when I say distance? Number's distance from zero. Speak up, what was that?
Like longer, like different from longer, different from zero, or number from.
So if I say distance, I'm talking about how far it is from zero, right? That's what I
Right.
mean when I say absolute value. I'm talking about how far that number is from zero. So the absolute value of a number is its distance from zero. So how far is that number from zero? Okay, that's what we're saying. How far is that number from zero? So when we look at absolute value, that's what we're looking for. And when we're looking for absolute value, we use two straight lines. And we put the number in between those two straight lines. So I have a number like 29, and I want the absolute value of 29, I'll put it in between two straight lines like that, right? 2 bars. That is the symbol for absolute value, just those 2 bars. All right, and so we'll see them down here in the examples A and B. Okay. So again, we will start with our 0 in the middle of this number line, and we're going to plot these 2 numbers that are in between the absolute value symbols. So we're going to plot 5 and -8. So 5 is going to be about over here on the right, right? We're just going to put it on the right because we know it's a positive number. And because 8 is negative, we're going to put it over here on the left. So to find the absolute value of each of these numbers, I just have to count the distance from 0 to 5 and then from 0 to -8. So from 0 to 5, it's 1, 2, 3, 4, 5 places. So the absolute value of 5 is just 5. So what's the absolute value of -8? Well, what's the distance from 0 to -8? How many numbers are in between 0 and -8? Well, there should be 8 numbers, right? 1, 2, 3, 4, 5, 6, 7, 8, right? Because in between here I have -1, -2, -3, -4, -5, -6, -7, -8. So the absolute value of -8 is just 8. So when we are looking at the absolute value of a number, if it's negative or if it's positive, it's just going to be the value of that number. So a lot of people will see this kind of a question on the GED practice test or on a GED test, and they'll be like, I never learned what these bars mean. I don't know what's happening. But it's really just that simple, right? So the value of the absolute value of any number is just the number itself and not its negative value. So I don't care that that negative is there because the distance from -8 to 0 is still just 8, right? So my absolute value is again just the distance from 0 for every number. Very good. Okay, yes. So then with that same idea in mind, it should be very easy to find the opposite of a number. When we're thinking about any number being either negative or positive, then its opposite has to be the exact same, right? So the opposite of a number is the same distance from 0. Both numbers have the same absolute value. So that means that the absolute value of 5 is equal to the absolute value of -5 because they have the same distance to 0. It's still 5 places. So any number that is the opposite of another number has the same absolute value. So the number that is the opposite of 2 is what? What's the opposite of 2? What's the opposite of +2?
-2.
-2. What's the opposite of -11?
What you say? I was a -11.
Positive 11.
Positive 11.
+11, right? And we don't need to chart that on a number line. We know that. We understand that. So any number that is its opposite has the same absolute value, okay? So that's just a concept we have to understand and know. We'll talk a little bit more about absolute value when we actually have to do math that includes absolute value. But just so you know, it is not a very complicated concept. It is just that idea that the distance from of a number from 0 is that number's absolute value. And the opposite of a number has the same absolute value as the original number. So 2 and -2 have the same absolute value. It's just 2. Okay? All right. We're gonna wrap up these notes here. We have a couple more things to do. All right. So let's talk about integers in the real world. How do we represent integers in the real world, or how do we use them to represent situations? So what number would represent the following situation? So it says a hawk, which is a bird of prey, right, descends at 150 miles per hour when striking its prey. So what number are we dealing with in letter A? What number do we see?
150.
150, right? So how do we represent what's happening with the hawk descending? How do we write that as an integer or as a number? What do we have to do to represent descending? What does descending mean to you?
Negative. So it would be -150.
Very good. So it's -150 because descending means to go down. And so to represent that, we have -150, right? What's a situation besides this where you would see negative numbers? What's a real life situation where you would see negative numbers?
And temperature readings.
Where?
Temperature readings.
Your
When it's
temperature
like
readings?
negative
Yep.
degrees or something.
That's very true. If you're looking at Celsius, you're going to see negative numbers for your temperature reading. Absolutely. Normally in Fahrenheit, we don't want to see negative numbers because that's really, really cold. But yes, during the winter, we have had situations where we've had negative numbers. Very good. Is there another situation where you might see negative numbers? Where we don't want to see negative numbers, maybe?
You check.
Yes. Your checking account, right? We don't want to see negative numbers there, but we see it all the time, right? Anytime you write a check or you withdraw some money, what happens? It shows up as a negative number, okay? All right, and then the final situation, a skier wins a downhill race by skiing at 126 miles per hour. So if they're going downhill, how do I represent their speed? What am I gonna do?
I'm gonna think like you put a negative 126.
Very good. So still -126. All right, because they are going downhill. Even though they are racing at 126 miles per hour, because they are going downhill, right? It's a negative number that I'm going to put as their speed. Okay. All right, we're going to do some practice. We've learned a little bit about these numbers. Oh, your audio's not working, Danielle. I'm sorry. So Danielle, if you have a Academy of Hope computer, make sure you call that help desk number after class today. Okay? Call the help desk number and they can try to help you figure out what's going on with your audio. I apologize. But yeah, just go ahead and continue to contact me via the chat if you have any questions or anything. I'm sorry that you can't speak right now. Okay. Let's try to sort these numbers into being rational or irrational. Remember, if they are rational, they can be written as a fraction. If they're irrational, they cannot be written as a fraction. Okay, so let's try it. So 0.8, can that be written as a fraction or can it not be written as a fraction? So is it rational or irrational? 0.8.
Oh man.
Rational?
Hey.
Yeah?
Hey.
Yeah.
Okay,
Okay.
it is
Rational. It's a rational. So
rational.
Hello.
rational.
0.8 is rational because that can be written as a fraction. 0.8 is actually just 8 over 10.
8/10, yeah.
Yep. So it can be written as a fraction. So anything that can be written as a fraction is considered rational. So even though this does not look like a fraction, this can actually be written as a fraction. Okay. So 0.8 works there as a rational number. Okay. All right. What about, let's go to an easy one then. 3/7. Is that
Yeah.
rational or irrational?
Rational,
Rational.
Rational.
because it is a fraction.
Because it is a fraction. Perfect.
Yeah.
All right. It's got difficult now. What's the square root of 64? Is that rational or irrational?
That's a rational.
How? Why is it rational? You're right, Marvin, but right. But why?
Cause 64, cause you put like 64, a square root of 64. That mean nothing that they had not a fraction. You don't know.
It's
So
the
the
same
square
number
root of
itself.
64 is what? Does anybody know what the square root of 64 is? The square root of 64, right? We'll get to square roots a little later in this class in about 2 weeks or so. We'll talk about square roots. The square root of 64 is 8 because 8 times 8
Yeah,
is
64.
equal to 64, right? So
Right.
the square root of 64, they just ask you to find out what number can be multiplied by itself to give you 64, right? What
Right.
that
I knew
number
something.
is 8. So the
Right.
square root of 64 is just 8. All right, so we don't have to,
Yeah.
you have to think about it as that square root because the answer is actually
Right.
8. Okay.
Yeah, cause I know 75. 75 is square root of
We're not
75.
there yet. Wait, hold on.
No.
I want to make sure nobody has any questions about 64.
I basically asked a question. No?
Okay, 1 second. All right, so square root of 64, we're good. We're going to move on now to the square root of 75. Go ahead. Say what you were going to say, Marvin. What's going on with
That
square root
was-
of 75?
I was saying the 75 is that it's really honestly it multiplied by something to give you 75. It makes it at 25. It makes it 25. Well,
Yeah,
I'm
so
okay.
the square root of 75 is not going to be like the square root of 64. So the square root of
No.
64 is a perfect square. And we know it's a perfect square because 8 times 8 is 64. What's 9
Right.
times 9?
81.
81. So 75
Right,
is
yeah.
in between 64 and 81. So we know it's not a perfect square. So it can't work out to a whole number the way that 64
So
did.
it's irrational.
So it's irrational because it's
Irrational.
not a number that can be written as a fraction, and it's not a whole number. So the square root of
Right.
75 is irrational. It's going to give us a decimal. So if we put that into our calculator, if we pull out a calculator, and I will show you guys how to use a calculator. Probably on Wednesday, I'm going to show you how to download a calculator for your computers as well. But when you put this into your calculator, you're going to get a decimal number. And I can show you that. All right. So the square root of 75, let's see if it'll show up. Oh, maybe not, no.
Yeah, I still can't see what.
All right, here's what we're gonna do. We can do these things.
75 times 9. Let's see, I know 75.
All right, so try that. There we go. So that is the square root of 75. It is a decimal, it's a non-ending decimal number. I can't write that as a fraction, okay? It's 8.6602, that can't be written as a fraction. But the square root of 64 is just 8, okay? So that's the difference between rational and irrational, okay? We're talking about a number that can be written as a fraction, because 8 can be written as a fraction, versus a number that cannot be written as a fraction. Okay, let's try the next one. 0, is 0 rational or irrational? It's a rational number.
Rational. Rational.
Okay. It is a rational number. So
I
let's
have a
put
question.
0 over
You
here.
said- So 0 is a rational number? I thought you said only rational numbers can be numbers you put into a fraction.
So 0 over 1, right? That's a
A
fraction,
penny.
but
Like
it's
a
still
penny.
0,
Okay, all right. I got
right?
it. Thanks.
Anything that I can write as a fraction. Good question though, yes. All right, what about 6 and 2/7? It's a fraction. So that means it's rational,
Rational, yep. Simple.
okay? All right, the square root of 32. Again, we have to think about our perfect squares. Our perfect squares are the result of numbers whole numbers that we multiply together. So 5 times 5 is 25. Well, what's 6 times 6?
6 times 6. 36.
So 32 is in between 25 and 36, right? That means it is just like 75. It is
And
irrational.
not irrational.
It's going to give me a long decimal number when I put that in my calculator. So the square root of 32 is also irrational. Okay, what about 12.67 with this little bar over it? What does this bar mean? Anybody know what that little bar over the 7 means? So that bar means that the 7 is repeating, right? It keeps going and going and going and going and going and going and going.
Right.
Okay. So if we have a repeating decimal, right? A repeating decimal in some cases can be, and in most cases will be, written as a rational number. 12.67 is the same as 12 2/3. Okay, it is a rational number. You guys stick with me. You guys are going to learn so many things about numbers. So 12.67, this bar means that it's repeating. It's going to go on and on and on forever.
All the way.
But 12.67 is repeating, and 2/3 as a fraction is actually written as 0.67 repeating.
Are you going to show us how you got that? It's
I was just about.
Okay, so we haven't done this yet, so it's not something that you have to necessarily remember, but I'll tell you right now. When you turn a fraction into a decimal, so if I have 2/3, how do I turn this fraction into a decimal? What do I have to do? Some of you might remember.
Multiply.
We don't multiply to turn a fraction into a decimal. We actually divide. You have to divide
basically
2 by the 3. Okay. So let me pull up a blank sheet. I'm gonna do a new share. I'll pull this right back up in a second, guys. Let me cancel that. All right. Let me go back to this. Let me save this. All right.
My apologies.
You're fine. Okay. So if I have 2 over 3, and I want to turn that into a decimal, I divide the 2 by the 3, right? So I put the 3 on the outside and the 2 in the inside.
Mhm.
Can I divide 2 by 3?
No, it'd be 0.
No. So what I need to do is add a decimal
Yep. That's right.
and a 0. Now I can divide 20 by 3, right? How many times does 3 go into 20?
We can go into 20 like 18 times because 3 times 6 is
Not
18.
18 times.
No, 3 times.
How many times does 3 go into 20?
6 times.
6 times.
6 times. That's why I
What's
was gonna
6
say that
times
was
3, Marvin?
18.
There we go. That's what we were looking for. Good. All right, so 6 times 3 is 18. When I subtract 20 minus 18, what do I get?
2.
2. All right, so I need to keep going, right? How do I keep going? I have to add another 0. So what's going to happen when I bring that down? It's going to become
Going to
20, right?
20 and then be
How many times does 3 go into 20?
6. Okay.
6 times.
6 times. So it'll be like
It's gonna do what?
18 and it go.
But what's going to happen? It's going to keep what?
I'll go on, keep going, keep
It's going
going
to
and
keep
going.
repeating, right?
Going
So
and
when I
repeating.
round it up, what am I going to round it to? 0.67.
6, 0.67, yeah. And then
Okay, and then you
Okay.
put the little line over top of the 7?
To indicate
Okay,
that it's repeating. Yep.
all right, I got it.
Okay. So that's how that happens. All right. So when you turn a fraction into a decimal, we're just dividing the numerator by the denominator. Okay. All right. That was a good question. I'm glad you guys asked that. All right. Let me reshare our document. All right, so we were at 12.67. We're now going to go and do the next one. So negative 19, is that a rational number or an irrational number? Do we need to go back to our chart? Let's go back.
It's a rational.
It's rational, definitely. It's a rational number, right? So any number that can be written as a fraction is considered a rational number, right? So negative 19, if I put a 1 over it, under it, I'm sorry, it becomes a fraction. So it's a rational number, okay? All right, we're back to more square roots. The square root of 121. So what's 10 times 10?
10 times 10, 10 times 10,
100.
100.
Okay. What's 11 times 11?
100, 120, 121.
121. So that means the square root of 121 is 11. So that makes this a rational
number.
Okay. Whenever you're multiplying a 2-digit number by 11, all you do is split it up and then add the number in the middle. So what's 11 times 15? You split the number 1 and 5, and then you add it together. What's 1 plus 5?
6.
So 11 times 15 is 165.
165.
You split the number and then you add it up. That's how you get any number, any 2-digit number times 11. If you don't believe me, try it on your own. Multiply 11 times 21. Split the number, so you have 2 and 1, and then the number in the middle, you add it together. What's 2 plus 1?
2 plus 1 and 3.
So that means 11 times 21 should be 231. Try it on your phones, try it on your calculator, see if it works. But There's a quick system for you to learn how to multiply by 11s. Anyway, I digress.
Mm.
All right,
Yeah,
back to this. Negative square root of 100. So what's the square root of 100? We just did it. What's 10 times 10?
100. 100.
So the square root of 100 is just going to be 10. So again,
Yeah.
this is another rational number.
Right.
Okay. What about 12 over 5? It's a fraction, so it has to be rational, right?
Rational, yeah.
All right, and then this one, 2.34344344444. Rational or irrational?
That's, I think that was hard for to blame me. I think, to my thing, it shouldn't be irrational. That's irrational, because that's like.
So this is irrational because it is not a number that is repeating, right?
Right.
It actually has different numbers of 4s every time.
Yeah.
So it's not the same number. 3, 4, then 3, 4, 4, then 3, 4, 4, 4, 4, right? But it's non-terminating and it's non-repeating, so it's irrational. What about pi?
Pi.
Is pi rational or irrational?
Pi, they say 3.14, so basically that shouldn't have been.
Pi is not 3.14. We approximate pi to be 3.14.
Yeah, approximately,
but pi never ends. Pi is never ending, so it is
irrational.
Irrational. Pi is 3.141592645. It goes on and on and on. Right?
No,
it's not repeating. So if it repeats, it's rational. If it doesn't repeat and it's non-terminating, it is irrational. Okay, so we are now able to sort them into 2 different categories. All right, so we have sorted our numbers. All right, I'm going to stop this share for a second, and I'm going to show you all your assignments for this week, so we can make sure you guys see what you have to do for this week. And if there's questions, we can go over them as well.
Yeah.
Okay, so let's share my desktop again. Okay, so in your folder for week 1, again, make sure you fill out your discussion question by Wednesday. These notes should be filled out and turned in as well. So if you need to go back and review the notes that we just went over here in class, that's fine, but whatever them together. So the idea is just that you have the notes, you've written them down, and I know that you have them. The handout here, if you click on this handout, it'll break it down for you what we talked about into a nice little display. So what your natural numbers are, what your whole numbers are, what your integers are, and what your rational numbers are, and what your irrational numbers are, okay? So it gives you a very good simple little breakdown in one place what your real numbers are. So that handout is available to you. Additionally, you guys have a couple of practices to do, just 2 practices and an exit ticket. All of this work that's here is due by Friday at 5 p.m. And when you turn it in by Friday at 5 p.m., I'll be able to give you guys all the attendance credit for the week. Remember, you still need to attend class on Wednesday as well to get the attendance credit for that. But here are the practices. All right, so they are assignments. They're available in a Word doc or as a PDF. You can open up the PDF in Kami to make sure that you can do the assignment there. And of course, the beauty of doing it in Kami is that you can mark up the PDF and it saves a copy for you. And then you can also click the turn in button in the upper right-hand corner right here, right? So in this assignment, you guys are going to look at these numbers and tell me if it is real, rational, if it's an integer, it's a whole number, it's a natural. So check off whatever you think applies for each of these numbers. All right. And if I do my little text box, I can do a text box and insert my text box and click what I think each number is. For example, I'll do the first one for you. So I have -6. -6 is a real number. It is a rational number. It is not irrational. It is an integer, right? It is a -6. Okay, so that's how you would do that assignment, right? You just put an X for everything that applies for each number. All right, so let's try one of them together. I'm gonna make this a little bit bigger so we can all see it better.
I can see it, but
That's fine. I'm just gonna make it a little bit bigger just in case. All right, so let's do, let's do the hard one, so you guys don't have to do it on your own. Let's do pi divided by 2. Is that a real number?
I'll say yes.
Yes, it's a real number because we're only working with real numbers in this class. Okay,
In the class.
we are not doing any imaginary numbers. So it is a real number. Okay. Is it rational or irrational?
Irrational.
It is irrational. All right. It is irrational, so that means none of these other things apply because integers, whole numbers, or natural numbers are all types of rational
Rational.
numbers. Okay. So pi divided by 2 is a real number and it is irrational. Okay. So that's what you're doing for number 1. All right. And then number 2, you're just going to give examples. Numbers 2, 3, 4, and 5, you're just going to give me examples of different kinds of numbers. So a number that is an integer, but not a whole number. Anybody know of a number that is an integer, but not a whole number?
0.
0 is both. 0 is both an integer and a whole number.
What about a -1?
Perfect. Any negative number would be an integer, but not a whole number. Very good. Okay. And let's see. Let's also do number 5 together. A number that is an integer, but not rational.
Could I say a negative decimal or a negative fraction?
This is a trick question. There's no such thing. Because what are the 3 kinds of rational numbers? Integers, whole numbers, and natural numbers. So there's no such thing as an integer that is not a rational number. Okay? It's a trick question. That's my, are you paying attention question? Okay. All right. So integers are a type of rational number. There are 3 types of rational numbers: integers, whole numbers, natural numbers. Okay. So that's your first practice that I need you guys to do. Pretty straightforward, hopefully not too taxing. Let's take a look at the next practice. All right, so practice number 2 on understanding numbers. So practice number 2 on understanding numbers is an IXL link. So do make sure you're logged into Clever, because if you're not logged in, I'll show you what happens. So you go to IXL and you can see right here, I'm logged in, right? It says, welcome, Mr. G. You'll know if you're logged in because it'll say welcome and it'll say your name up here in the corner. But let me sign out just to show you what's going to happen when I try to do this. I'm going to click on this, and if I'm not logged in, just like I'm not logged in here, it'll let me do a couple questions, and then it'll tell me that if I want to do more questions, I need to sign in, okay? So always make sure you're signed in the upper right-hand corner, and it's just, it'll automatically sign you in if you sign in via Clever. But the idea is you're going to do the same thing. You're just going to do it in a more responsive fashion. You're going to sort the numbers into rational and irrational, but this program will also help you learn, all right? So 2, is that rational or irrational? The number 2, is it rational or irrational?
That's a rational.
Rational.
That's rational. What about the square root of 22?
Rational.
That's irrational. I'm just gonna skip ahead for that one. So if I have 2 plus the square root of 22, square root of 22 is still irrational, right? So anything that includes that should be irrational as well.
That's an irrational.
So you're gonna click submit, and then you got it, right? So you got it right, but let's say you got it incorrect. So let's say I put that there, and I put these here, then I click submit. So it's incorrect, and it'll explain to me why it's incorrect, okay? So this is just a more responsive way to do the same thing I'm having you do in practice 1, but this way you get to also be teaching yourself as you're doing it, okay? So if you get something wrong, it'll show you why it's wrong and explain it to you, okay? But do make sure you're logged into the program, or else it's not gonna work properly for you, right? And then also it won't tell me that you've done the work. And I'll be like, Danielle, why didn't you do your work this week? Right? So make sure you are logged in. Okay. All right. So we have about 15 minutes left of class. What questions can I answer for you?
Is this about what we did today, or is this about school overall? Because I do have some general questions.
Okay, well, I'm going to start with questions about this for right now, and then I can answer some general questions. Okay, so there's any questions about today? Everybody's okay with today? Speak now or forever hold your peace.
Okay, yeah, that's the one.
All right, okay,
The
go ahead, Danielle. Ask away.
So the only questions that I kind of sort of have is, have they sent out a schedules yet?
So you should have a schedule in your AOH email. If you haven't received the schedule in your AOH email, I can ask them to resend it to you. So did you not
Okay,
get
because
one?
I don't think that I have one. The
Okay.
only thing that I see are so the schedule that I did get was the old schedule, which has times of 5 a.m.
Okay.
So I don't have a basically clear schedule. I don't know where I'm supposed to be, what I'm supposed to be doing. I know I only get emails from you and Miss Latifa. So I don't know, and workforce. So I know that I have those 3 classes, but I don't know which days, what times.
Okay.
To be specific. So I just need to make sure that I'm attending all my classes that I'm supposed to be in.
Okay, good. So I'll have it resent to you then so that it is more clear. But yeah, so because I don't know when your workforce class is, but I know for a fact that Monday and Wednesday you have me at 9 a.m. and then Tuesdays and Thursdays you have Miss Latifa. And I know that everybody who's on here right now should get another email with a new schedule anyway, because they have to put your Friday schedule on there if you have a Friday class. I will specifically ask them to make sure they resend yours so that it's very clear when you're supposed to be in class, especially because you have that extra workforce class. So that's going to be a different schedule for you.
I would also need one too, because it says the same thing for me for 5 a.m.
Yeah,
So
put that
there's
on there.
no 5 a.m. class for anybody. Let me just make that clear as well. Anything that says homeroom, that is not a class that you need to attend. That homeroom class is just so that we can push announcements out to you. And they had to put a random time there. And I don't know why they chose the time of 5 a.m., but they did. And that's why it's showing up as like a 5 a.m. commitment, but you do not have to be anywhere at 5 a.m. You don't have to
Okay.
log into anything at 5 a.m. and there's no work required for you to complete that class.
So there's no evening classes at all. It's just going to be all AM.
There are evening classes. Are you supposed to be in the evening program, Morris?
That's why I'm asking the same question.
Okay.
I'm quite not sure.
Yeah. So so if you're supposed to be in evening, I'll just let Miss Claudia know that she scheduled you for the wrong classes because there are evening classes. So you should be in the evening. And you don't have to wake up at 9 o'clock with me if you don't want to.
Right,
I appreciate that. Thank
I mean,
Right, but I would.
everybody should want to wake up at 9 o'clock with me, though. I mean,
Yeah, I know. But I don't know. But the thing I would say too, another question about the last part when you on the ISL when we talk about 2 plus the square root of 22. Because to me, that's not like a harder question to figure that out when you're saying like you put a plus sign and put a square root. 'Cause, I mean,
no. So the question is, if the square root of 22 is irrational,
right.
then anything with the square root of 22 is going to be irrational.
Right, but I was saying about the plus
square root
sign.
of 22 is irrational.
I mean, yeah, but I know, but you put the plus sign on it, and I don't think that's like not like hard to figure that out when you put the plus sign in the square root. But
Again,
that's not what I was thinking. But
the thing is that because there's the square root of 22 is an irrational number, anything with the square root of 22 also has to be irrational. That's what I'm saying.
okay,
So if
okay.
you have a number that has a square root that is irrational, anytime you include it, that number is going to be irrational. That's just like with pi. When we did the example where I said pi divided by 2, because we know that pi is irrational, it doesn't matter that I divided by 2, it's still going to be irrational. Okay? So once you determine that a part of a number is irrational, every time you include that part, it's still irrational.
Okay.
Okay?
I'm there.
All right. So for your schedule for the week, as far as math goes, and if you have me and you're not going to be switching out because you're going to evening classes or something else is happening, make sure you have your notes uploaded into the system by Wednesday at 5. Make sure you answer your warm-up question by Wednesday at 5 as well. And then everything else, the other 2 practices and your exit ticket are going to be due on Friday. So try it out between now and Wednesday's class so that you can ask me any questions. Because that's the benefit of having me on Wednesday as well, right? You can ask me questions about the practice since you now have this break, right? But Wednesday at 9 o'clock, come back and ask me any questions. We'll also do just another activity to help you understand the number system a little bit better. But I'm not going to be adding any more work to the week, right? So all of your work is posted. So you have a chance to just do it all now and then ask me questions about it on Wednesday, right? To make sure it's perfect. Okay?
One more
All right,
question.
y'all.
One more
Lastly-
question.
Yeah.
On iExcel, am I doing the recommended assignments on iExcel, or am I just?
So in general, if you want to practice on iExcel, you can do the recommended assignments, but there's always going to be a practice that I want you to do based on clicking this link here. So if you go in here, you want to do these 3 links that I've put in here, right?
Okay.
But if you want to do additional practice, you can always do those recommended practices as well.
Okay. Thank you.
All right.
All right. And I'll check the chat real quick. Okay. All right, everybody. So have a great day. If there's no more questions, I will see you all on Wednesday.
Okay.
Thanks again. Appreciate
I see
No
y'all then.
problem. Have a good one, y'all.
See you Wednesday.